On this video, I'm going to talk you through finding both volume and surface area of the shape, which is on problem number 39 on page 154 in your textbook. So let's start with surface area, and the formula that we're going to use is 2 bases plus perimeter times height. And I would like for you to do this the way that I'm teaching you, even if you have a different way to do it. I'm trying to give you a method that I would like to use on all of these shapes. So the B in the formula stands for the area of the base. And you can see that the shape is the same on the top and bottom. That's why you multiply it times 2. So I've got a base shape here, and then the bottom is exactly the same. So that's the 2. The P stands for the perimeter of the base. And then H is the height of the box, the height of the object. So we're going to calculate the separate pieces and then pull this all together. So this work is a lot about staying organized as much as anything, and I'm trying to give you a method that I would like for you to use when we do these problems over the next week. So the first thing I would like to do is calculate the area of the base. And I'm going to draw it here and kind of cut this up. There are several ways to do this. I'm just going to present one method on this video. So each side that you're looking at is X. And one way to calculate this is just one method. One way to calculate it is to figure, just to assume that you've got a solid piece with little cutouts here. So if I'm going to go with the solid, this is going to be a 3x by 3x. So my solid area would be 3x squared, which is 9x squared. But then I would have to come and subtract out the little pieces that I've cut out. And each of these pieces is an x by x. So I would subtract from this 4 cutouts of x squared. So that means that the area of my base is going to be 5x squared. And as I said a minute ago, there is definitely more than one way to arrive at that answer. I'm just giving you one option. The next piece of information that I need for my formula is the perimeter of the base, the perimeter of the shape. And several different ways to do that as well. But I have 12 sides here in blue, and that would be the perimeter of this base. So the perimeter of the base would be 12 sides, each side at a length of x. So my perimeter is 12x, so I would just start counting the 12 sides here in the blue. So I find the area of my base, and then I take the perimeter of that same shape. And then the height of the object, so my perimeter is 12x. The height of the object, the height of the box is 3x. So the height is 3x. And I'm going to arrange this information into my surface area formula. So here's my formula. And you will be responsible for this. 2 bases plus pH. So my surface area will be 2, and my base area is 5x squared. And then my perimeter is 12x, and the height of the box is 3x. So cleaning this up, I have 10x squared plus 36x squared. Notice I have like terms, both raised to the power with variable raised to the power of 2. So the surface area of my solid is 46x squared. That's my final answer. That's my surface area for the solid box. Now the book does not ask you to calculate volume, but I'm going to go ahead and calculate volume as well. And the volume would be the length, width, and height. So if I stayed with the same theme of if I were to calculate the volume of a solid box, the volume of the solid box Well, that would be pretending like I had no cutouts, and I would just be finding the volume of a solid. This would be a cube actually, and I would be 3x on all dimensions. So if I were to calculate the volume of the solid, it would be 3x raised to the third, which is 27x cubed. So one way to do this is to find the volume of the solid box, but then you would have to subtract out the cutout pieces. So I've got 4 towers that are x by 3x. So I have 4 of these that I would have to back out, and I'll highlight them. So if I chose to go with the solid box first, then I would be subtracting 4 at a single volume of x by 3x. So I would have 27 minus 12, and then the volume of the cutout, or the volume of the solid that I'm looking at with the cutout pieces, the total, let's just call this the total volume to answer our question. The total accurate volume would be 27x cubed minus 12x cubed, and that's going to give me 15x cubed. So it's not difficult, but you're using properties of exponents, you're visualizing what's happening, and you definitely have more than one way to arrive at the correct answer.